So taking unity as a cube h, the number denote the distance above the projected face. The 0 and half number are for the cube corner and face center atom of the first sublattice, while the number 1/4 and 3/4 are those from the second sublattice. So this will give you a good idea of the atom distribution in such a structure. So you can see from here. So this white color atom belong to the same lattice, sublattice, and then the black one belong to the other sublattice. And the distance between the first sublattice and second sublattice is 1/4. So which explain this statement lah. Where is it? Inside. Okay, explain that it displayed by 1/4, two sublattice. Okay, this is the last session for this chapter 4. So the hexagonal zinc sulfide structure. So the vertical axis of hexagonal zinc sulfide is a 6-fold screw axis, while for cubic zinc sulfide is a 3-fold axis. So the stacking sequence is 0, 1, 2, 0, 1, 2, 0, 1, 2, and 0, 1, 0, 1, 0, 1. These are similar to the FCC and HCP structure. Okay, this is about the polymorph. For zinc sulfide, when you crystallize it, it can have different arrangement. The first arrangement is arranged in this way. Okay, so we get layer 0, layer 1, layer 2, layer 0. So this is layer 0, this is layer 0. So these two layers are same. And then it's just like A, B, C layer. Okay, so this layer A, layer B, layer C, layer A. So you can see A and A are same. So when you have layer A, B, C, then it's actually the face, center, cubic, closed back structure. At the same time, if you use different parameters, like now you increase the temperature and pressure when you want to crystallize the zinc sulfide, then you have the different structure. Now it's arranged in this way. So you got A, B, A, B. So this is A, this is A. You can see same. This is B, this is B, and both B are same. So when you arrange in AB structure, then this is a hexagonal closed back HCP structure. And you can see that this ABC structure and AB structure essentially are different. When they are different, that means that they have different atom arrangement. That means that they have different symmetry. Okay, different symmetry. So for this hexagonal, it's actually composed of 6-fold screw axis. 6-fold screw axis, that means that the atom will rotate by 60 degrees and then displaced. Okay, displaced. And then whereas for this cubic, the face center cubic, is composed of 3-fold axis. That means that when you rotate 120 degrees, you will get back the identical atom. So the stacking sequence of ABC, and AB for the FCC and HCP will generate different symmetry. At the same time, the same type of the material like zinc sulfide, it can crystallize into two different arrangement. Okay, it's not necessary to say that okay all the copper must be in face center cubic, all the copper must be in simple cubic. No. Okay, when you apply different condition of the temperature, pressure, and so far and so on, then you may produce the different arrangement of the atom. Okay, so this picture show that how the 3-4 axis work. So you can see that this can rotate 3-4, and then this is how the 6-4 screw axis. So the purple one, you can see that it rotate by 60 degree and then translate. Screw axis what? Screw axis. See that 6-4 screw axis. Screw axis means rotate plus translation, right? But then for this one, it just rotate only. For 3-4, it just rotate because it's 3-4. Remember that you study in chapter 2. But then for 6-4 screw axis, then it will rotate. For this case, then it will rotate by the green one. For this one to this one, it rotate by 60 degree and then displace. Okay, this is what we mean by the 6-4 screw axis. Okay, so 6-4 screw axis. For this case, it's 6-3. Okay, I hope you still remember what I mean by 6-3. Okay. If you forgot already, then go back to the chapter 2 and revise the video recording or revise the lecture note. Okay, these are the tutorial questions. First, I want you to determine the net number of sodium ion and chlorine ion in the sodium chloride unit cell. This is just a test. It's just to test your understanding. It's a very simple. In the exam, the question could be much complicated lah. Okay, don't expect that this simple question will come out in the exam lah. The second question. The geometric arrangement of ion in crystal of lithium fluoride is the same as that in the sodium chloride. The unit cell of lithium chloride is 4.02 angstrom on NH. I want to calculate the density of lithium fluoride. The atomic mass unit can be obtained from the periodic table. Number 3, like what I had request you during the lecture, I want you to determine the ideal COA ratio and packing fraction for an hexagonal closed pack structure. Number 4, I want you to tell me the distance between the adjacent atom for the NaCl, which has a density of 2.167 gram per cm cube. The atomic mass unit can be obtained from the periodic table. Okay, I know you should know. I believe that you should know how to get the periodic table. So, with stacking sequence of a planar triangular net of hard sphere result cubic closed pack packing and hexagonal closed pack packing, elaborate the difference between these two closed pack packing. So, is face center cubic Bravais lattice? What about the hexagonal closed pack structure? What is the underlying lattice for the non-Bravais lattice? And how many atoms are there in the base 6? Okay, so these are the self-test questions that I want to do. And that's all for chapter 4. Okay, then we'll proceed to chapter 5.